So we're going to go through sheet number 12. So let me show you where that is. This is, I hope you can see this. This is sheet 12. The sheet 12 is on two sample test of hypothesis, right? So if you look at question 1, there are 5 questions, by the way. There are 5 questions. I will try to do as many as I can. Okay. If you go through question 1, here they're trying to compare 2 different types of boilers or something. You have type A and type B. And you're given the data and the sample means, right? And you're told that the boiling times are normally distributed with the population variances given by these 2. The first part of the question is to, the first part of the question is to see, is to test at the 5% level whether the population means are equal versus whether mu1 is greater than mu2, right? So mu1 is the, I guess, is the mean boiling time for type A. Mu2 is the mean boiling time for type B, right? And we are trying to test this versus this. Right now, you should recall what we did about 2 weeks ago. I don't know whether you guys remember what we did about 2 weeks ago. I showed you how to do. I showed you how to, like, when you have 2 samples, when you have 2 sample tests, there are different ways you can do the testing, right? So there's the first case where the testing for equality of means when the population variances are known. And these are the 3 rejection rules, right? So here we are assuming that the population variances are known, and these are the 3 hypotheses, and these are the 3 rejection rules, right? And then there's the second case. Let me show you all of them. This is the second case. Again, we are testing for equality of population means, but this time the 2 random samples have the common variance, which is unknown. In this case, the rejection rules for the 3 sets of hypotheses are these 3, right? And then you have case number 3, where once again we are testing for equality of population means, but this time the population variances are assumed to be unknown, right? Okay, and the rejection rules for the 3 sets of hypotheses are these 3 rules, right? And finally, the final thing we did about 2 weeks ago is this. Here we are trying to compare the population proportions. So you have 2 random samples from 2 different Bernoulli populations. So PX is the population proportion for the first sample, and PY is the population proportion for the second sample. And here we are trying to compare the proportions in 3 different ways. And these are the rejection rules, right? Okay, let's get back to question 1. Now, in this question, it clearly says that the population variances are known. So these are the 2 population variances. They are assumed to be known, right? And we are trying to test this versus this, right? So clearly, the rule that we need to use is under case number 1, right? And the rule that we need to use is this one here, right? That is the reject the null hypothesis if this is greater than this, okay? So that's the first thing. That's the first thing you must figure out. I mean, in test of hypothesis, always the first thing you must figure out is which rule to use. Because if you get that wrong, then you're in trouble, right? So here we reject H0 if the following is true. Okay. All right, guys. So let me put this in a box. Okay. And let me call this star, right? Now what I'm going to do is I'm going to compute the left and the right hand sides of star and then compare them and see if this inequality is satisfied or not. Right. Before I do that, let me write down the data that is given to us. So according to the question, the data that we have as follows. X bar is the sample mean for the first sample is 11.4. Y bar is 9.9. M is 10. Sorry, excuse me, where am I going? M is 10 and N is 12. Sigma x squared is 6.25 and sigma y squared is 9. And we are also told alpha is 0.05 or 5%. So this is all the data that's given to us as part of the question. Right now, what I'm going to do is to compute the left and the right hand sides. Right. If you have any questions, please feel free to use the chat room. Okay. So let's start with the left hand side of star. Excuse me. So this is the left hand side of star. And if you compute this, you will get 1.279. So this is the value for the left hand side. The value for the right hand side is gonna be, remember we are using alpha is 0.05, so this is gonna be 0 point, and this, if you read this off the table, this will be 1.645. Okay. Now comparing these two, you see that this number is not greater than 1.645. So hence we cannot reject the null hypothesis. So what you write is that there is no evidence against H0. All right, guys, is this clear to all of you or not? Hello, guys, talk to me. If it's not clear, please say so. I'm happy to go over it again. Okay, thank you. So this is part one of question one. Now part two, let's go back to part two of question one is asking you the following. What is the probability that the test will correctly reject H0 if the true value of mu1 minus mu2 is 2? So let's see how we can do this, all right? So this is question one, part two, right? So what the question is asking you for is the following: is the probability of rejecting H0 when conditioned on the fact that mu1 minus mu2 is equal to 2. Okay. All right. So this is, now if you go back to part one, remember this is the rule for rejecting the null hypothesis. So this is the probability that X bar minus Y bar divided by right? All right, okay. Now putting in the numbers, in, we know that in the question says that sigma x squared is 6.25, m is 10, sigma y squared is 9, n is 12, right? Greater than, and this guy is 1. Just a minute. Is it 1.645? Yeah, 1.645. Because we are using, remember, alpha is 0.05. Yeah. Okay, so this is given that mu1 minus mu2 is equal to 2. Okay. Right? Are you guys with me so far? All right. The next thing I'm going to do is the following. That I think I did a similar trick. You may recall some time ago that I did something like this. You see what I'm doing, okay? I'm subtracting a 2 and adding a 2, so I haven't changed anything really. Right. Okay. In the next step, I'm going to take this term here to the right hand side of the inequality. Right. So this becomes right. Condition on mu1 minus mu2 being equal to 2. Right. Okay. Now let me ask you a question, just to check your memory. What can you say about this? What do you think this is, and why? Now, what I'm asking here, condition on the difference of the population means equal to 2, that this has a standard normal distribution. The reason for that is as follows. I think I mentioned this earlier in one of the videos. I think it's a video on 2 sample confidence intervals, right? So I will write that down again in case you forgot, right? Let me write it down one more time. So suppose you have a random sample of sites N1, which are IID from normal with parameters this. And you have another random sample which is IID from normal. Yeah. And suppose these 2 random samples are independent of each other. That is, they are independent right? And then the following result is true. Then the following result, that is x bar 1, this is the sample mean for the first random sample, take away x bar 2, this I think this is a result I proved some time back. if you don't remember this result, please look back in the video. I think it's the video on the two sample confidence intervals, right? So let me put this in a box. So all right. So using this result, right, we can say that this guy here must have the standard normal distribution. Okay. Again, once again, the conditioning is not needed because we have used the conditioning to argue that this has the standard normal, right? So therefore, we can drop the conditioning, right? Right now, this probability, you can write it as 1 minus phi. Phi is the CDF of the standard normal at 1.645. Take away all right. And if you read this off the table for the normal distribution, and this will get to be 0.52. All right, so this is the probability of rejecting, the null hypothesis when the difference in the population means is 2. Guys, is this clear to all of you or not? Let me know if it's not clear. I'm happy to go over if it's not clear, guys. So are you sure all of you are okay with this? Thank you, Sophie. All right, so we're done with question 1. So let's go to question number 2 now, which is this. Okay, here you have 2 different types of tire, type A and type B. And again, we're trying to compare the means, right? And you're given the sample sizes, the sample means, and you're also told that the common variance is equal to 1.742. The first part is to use 5% level of significance to see there's a difference in the mean for type A and type B, right? So once again, this is a question on comparing the means of 2 different populations, right? And in this case, the common variance, the variance is known and is equal to 1.742, right? So if you go back to the formula sheet, this is the formula sheet I showed you earlier, right? The formula that we need to use, right, is this one, right? Because we are trying to test whether the means are equal or not, but not equal, right? So you need to use this as the formula for testing, right? And again, we are assuming that the population variances are known, but they are equal, right? So we need to use this. Okay, guys. Let me know if you should not follow. Okay. So right. So let's do the first part. The first part is okay. Before I do the first part, let me write down the rejection rule. Right. So we reject the null hypothesis if the following is true: x bar minus y bar in absolute values, right, divided by yeah. So this is the rule for rejecting the null hypothesis. Okay. All this stuff. Right, before I go ahead, let me write down what is given to us. We are told that M is equal to 25 and n is m n is also 25, and we are also told that x bar is 10.24, y bar is 9.76, and we are told that sigma x squared and sigma y squared are equal, and that's equal to 1.742, and alpha is 0.05. All right, this is all the data that's given to us. All right, so using this data, we can work out the left-hand side and the right-hand side. So let's start with the left-hand side. So the left-hand side of star is gonna be 10.24 minus 9.76 in absolute terms, right? Divided by, excuse me, 1.742 divided by m is 25, and the same thing, 1.742 divided by 25. Right, and if you work this out, this will be 1.286. So this is the left-hand side, of star, right? The right-hand side of star, we are assuming alpha is 0.05, so the right-hand side is gonna be this, yeah? And if you read this off the table, this is 1.96, right? So clearly, this is not greater than 1.96. So conclusion is that there is no evidence right? There's no evidence to reject the null hypothesis. Okay, guys. So that's the part 1 of question 2. Are you able to follow this or no? Or, I mean, do you have problems? Please let me know. Okay. All right. All right. Now to do the second part of question 2. Is asking you what is the probability that the above test will incorrectly fail to reject the null hypothesis if the true difference in means is equal to 1, right? So the question is, what the question is asking you, sorry, excuse me. What the question is asking you for is the following. So this is question number 2, part 2. So what it's asking you for is the probability of accepting the null hypothesis when the true difference between the population means is equal to 1. That's what, I mean, if you read the question carefully, it says will incorrectly fail to reject the null hypothesis, which is the same as saying accepting the null hypothesis when the true difference is 1, right? Okay, so this is what we want to find. All right, now we should go back to part 1. Because this is part 1. This is the rule for rejecting the null hypothesis, right? So the rule for the accepting the null hypothesis will be the reverse of this rule, right? So this is the probability do you see what I've done? Instead of greater than, I have less than or equal to, right? Okay, so this becomes We know sigma x squared is 1.742 divided by m. M is 25. It's less than or equal to this guy we already worked out is 1.96. Right, guys, are you okay so far? Right, the next thing you should do is to get rid of the absolute sign. I think I showed you how to do that earlier. Okay, before I do that, let me combine these two terms, because this, you see, this one and this one, they are the same, right? All right, so you can write it as the square root of 2 times okay. All right, the next thing I'm going to do you guys remember this formula that if you have something like z less than or equal to a, this is the same as saying that if you remove the absolute sign, this is the same as this. Do you remember this? You should know this from your math courses. I don't know which course, but which course it covers this, but I think maybe real analysis or something. Yeah, so this is, you know this formula, right? So I'm gonna use this and write the above as the following. Okay, right. All right, the next thing I'm gonna do, because the true difference between the population means is equal to 1, I'm gonna apply the trick I made in the last question, you may recall. So I'm gonna do this. I'm gonna subtract one here and add 1, right? You'll see why I'm doing this in a minute. Okay. All right, the next thing I'm gonna do is I'm gonna take the 1 here to either side of the inequalities, right? Okay, to the left and to the right. Okay, so this is what you will get. Excuse me. This is what you will get. On the left hand side, you get this. Right, and on the right hand side, you will get you will get this. Okay, condition on the difference in the population means being equal to 1. Okay. All right, now, because of the argument that I just showed you a minute ago, because of this result, which I mentioned, a few minutes ago, right? This guy here must have the standard normal distribution, right? Okay, by the same argument, right? So hence, you can write this probability as right? You can write it like this, right? And then in the next step, I'm gonna write this in terms of the phi function. So if you rewrite this as in terms of the phi function, you get this as the difference of phi at 1.96, take away okay, minus phi at minus 1.96, take away this, right? Now, if you read this off the table and calculate everything, this is what you will get. Let me check the answer. Let me try to check the answer. Yeah, you will get this to be equal to 0.24, right? Right, so this is the probability of accepting the null hypothesis when the difference between the population means is 1. All right, guys, so is this clear or what? Are you okay with this? So this completes the solutions to question number 2. Hello, guys, talk to me. Are you okay with this or not? Yes? Okay, thank you. All right, the next question I'm going to do, so I'm done with question 1 and 2, right? Question 3 is this. Again, you have two different drugs, A and B, right? Drug A is given to 33 people, drug B is given to 37 people, right? Okay, and you have the following numbers. So these are the 33 and the 37. These are the sample means, and these are the sample variances. And you're assuming that the data are normally distributed. So we want to use 5% significance level to test if there is a difference in the mean times to absorption of the two drugs. There are two parts. The first part is to assume that the variances are unknown and not equal. And the second part is to assume that the variances are equal, right? All right, now let me go back to the formula sheet. This is the formula sheet. Remember, this is the formula sheet I showed you. Now, in this case, we are assuming that the population variances are known, right? Okay, in these three rejection rules, we are assuming that the population variances are known. But in this question, clearly in this question, the population, what you're given are sample variances, right? And the population variances are not even given, right? Not even talked about. So hence, we need to assume that the population variances are unknown in this question, right? So hence, none of these rules can be applied, right? So this, okay, let's go back to the next sheet here. In this case, you're told that that the population variances are equal but unknown. But in the first part of we are assuming that the population variances are not equal. So hence, again, none of these rules can be used. Right, so let's go to the next page. Over here, we are assuming that there are two different population variances, both are unknown. Right, so in order to do the first part of this question, we need to use this rejection rule here, right? Because see, we are trying to test whether the means are the same versus that they are not the same, right? So the rule to use is this one, right? So you see, so it's really important. It's really important to figure out the correct rule to use, right? Because if you get it wrong, if you get the wrong rule, then you get no credit for your answer, right? You get no credit for your answer. So it is really important. It's really important that you do get the correct rejection rule before you start doing the calculations, right? All right, so let me start with question 3. So this is question number 3, part 1. Okay. So the rule that I'm going to use is the following. Right, this is the rule that I'm going to use. Okay. So let me put this in a box one more time. Right, so as usual, I'm going to compute the left and the right hand side. Before I do that, let me write down what's given to us. Right, we are told that m is equal to 33 and n is equal to 37. We are told that x bar is 28.2, y bar is 30.7. We are told that s x squared, the sample variance, is 16.36. The sample variance for the second sample is 18.92. We are also told alpha is 0.05. All right, so these are all the data that is given to us, right? So we can now compute the left. So let's start with the left-hand side. Right. Yeah. Now, if you compute this, if you work this out, you will get this to be 2.49. So this is your left-hand side. Right. Now let's come to the right-hand side now. TA, alpha is 0.05, right? So 1 minus alpha by 2 is 0.975. All right, now this is where the problem comes, because if you go back to the formula sheet, if you go back to the formula for A is very complicated. I don't know whether you remember. This is the formula for A, which is pretty clumsy to work out. Okay, so if you can avoid that, it's best to avoid. It's best to avoid working with A if possible. Now, in this case, it is possible to avoid working with A because if you look at the sample sizes are 33 and 37, which are large because in statistics, anything about 25 is considered large, right? And both these are clearly above 25. So in that case, this can be approximated by the Z percentile, right? That's the reason for this approximation is that these two sample sizes are large, right? And this is easy to work out using the normal table. This, right? And it's very easy to find out this equal to 1.96. So the left-hand side is 2.59 and the right-hand side is 1.96. And clearly the left is greater than the right, okay? So the conclusion is that there is evidence to reject the null hypothesis. Okay, guys. All right, so that's the first part of question number 3. Now the second part of question 3 is asking you to do the same thing, assuming that the population variances are equal, right? All right, now let's go back to the formula sheet again. Should go back to the formula sheet. Right, in this case, we are not assuming that the population variances are equal, but we are just assuming they are not equal and unknown, right? Now, if you go back to this, right? Here, we are assuming that the population variances are equal and unknown. In this case, the test for this versus this is this. So this is the rejection rule that we should use to do the second part of question 3, right? So I'm going to use this, right? Okay. So this is part 2. This is question 3, part 2. So we reject H0 if X bar minus Y bar divided by is greater than T m plus n minus 2, 1 minus alpha by 2, right? So this is the rule I'm going to use, because I'm using this rule because we are assuming that the population variances are equal and unknown, right? So let me put this in a box, right? Right, and call this star, right? Now, in order to work out the left-hand side, first we need to work out this guy here. This is, I don't know whether you guys remember this. This is known as the pooled sample variance, right? And it's given by this formula here. I mean, if you look back in the notes, the videos for 2 sample confidence interval, you will see this. This is the formula I gave you, right? Now, for the data that we have, in question 3, part 2, right? M is 33, so it's 33 minus 1 times Sx squared is 16.36. N is 37 minus 1 times 18.92, right? And you divide this by m plus n, which is 33 plus 37 minus 2, right? And if you work this out, you will get 17.715. Right, so this is the pooled sample variance. So this implies that the left-hand side of star is going to be equal to the following: 28.2, which is x bar, minus 30.7, which is y bar, divided by the square root of 17.715 times 1 over m, which is 1 over 33 plus 1 over 37. Right? Okay, and this will be equal to 2.481. All right, so this is the left-hand side. This is the left-hand side of star, right? Now to compute the right-hand side of star, okay, to compute the right-hand side of star, you can approximate this by the z percentile, because n plus n minus 2 is large, right? But this is not too difficult to read from the t table, so I'm gonna use this without approximation. Okay, it's up to you what you want to do, right? So this is t 33 plus 37 minus 2, comma 0.975. Right, 33 plus 37 is 70. So this is 68, comma 0.975. Right? Right, and if you read this off the table for the t distribution, I'm sure you know where to find this table, right? It's in the course website under the link called formulas. Right, so you read this, you will get this to be 1.995. So this is the right-hand side, and this is the left-hand side. And again, the left is greater than the right-hand side. Okay, so the conclusion is that there is evidence against H0. Okay, so that completes question number 3. Are you guys okay with this or not? So you see what we did in this question number 3. We used 2 different rejection rules for the first part. For the first part of question 3, the population variances were unknown and not equal. So we used 1 rejection rule for that. For the second part of question 3, the population variances were unknown but equal. So we use another rejection rule for that, right? So these are all from the formulas that we learned 2 weeks ago, right? Okay, guys, any questions, please? All right, so we're done with question 3. All right, so the only questions that I haven't done are 4 and 5. Unfortunately, I run out of time, so I will post the full solutions to all 5 questions on the course website on Thursday of this week. So please have a look at the solutions when you have time. And by the way, about the exam, I think because we had some confusion earlier, did you get my email about the exam, the final exam? The final exam will be take-home exam. It will be 2 hours long from 9 to 11. And you will be given an additional time to upload your answers to Blackboard, okay? And the exam will be open booked. All right, guys, so any questions about the exam, just feel free to contact me 24/7 by email, Skype, Zoom, or phone. And I'm also happy to meet you in person if you are in Manchester, right? All right, guys, so have a great evening wherever you are. and take care of yourself, right? And I will talk to you soon. Okay. All right. Take care.